This is regular physics, sample problem, chapter 34. All right, so that's where you should be. You should be in chapter 34, sample problems. All right, so let's see what it says. A 20 ohm resistor has a potential difference of 10 volts across it. What is the current flowing through the resistor? All right, so I'm going to use my ohm triangle. So I'm going to draw it over here to make my life easier. So V, I, R. So you should just have that all over your notebook, all over the place, so you don't do it upside down. So in my given, I know that 20 ohms is my resistance. So R equals 20 ohms. And the potential difference, I know that's a weird word, right? But potential difference, oh, now you can't read anything. But the potential difference, right, this word where it says potential difference, that is my voltage, right? But it says 10 volts, so that helps a little bit. So V equals 10 volts. And we're trying to find current. The letter for current is I. I know it makes no sense, but that's what it is. And so I look over at my ohms triangle and I say, okay, I want to find I. So it looks like it's V over R. So I'm going to write I equals V over R. Cool. Solved. Compute. I is equal to 10 volts over 20 ohms. The math is easy. 10 over 20, 1/2, 0.5. 0.5, that's a point. That's a 0.5. But then the units are weird, right? Volt over ohm. So you just have to know that current is measured in amps, right? Amperes or coulombs per second. All right, that's the first one. Let's try the next one. A wire has 30 coulombs of charge every 5 seconds. What is the current? So let's see. Given charge. Charge is Q. It's a while ago since we used that, right? And 5 seconds, that's easy. That's time. I can't use ohms triangle. Sorry, this one is not an ohm triangle one. Can't do that. Okay, so we know that the time is 5 seconds. I don't know what happened to that. Sorry, I got interrupted there. So that's 5 seconds. That's really what that says. That does not look like a 5. There, now it looks like a 5. So 5 seconds, and we're trying to find current. That's still that I, right? And so the equation is I equals Q over T, charge per second. So that's already solved. So that means I is equal to, let's see, what was Q? 30 coulombs. Oh, nice, easy math. I love it. 30 divided by 5 is 6. Remember, a coulomb per second is an amp. And so we end up with 6 amps. Okay. Third question. What is the resistance of a resistor that has 120 volts across it and is causing 25 amps to flow through it? Ah, this is another ohms triangle. If I know I have V, I, and R, I know I do V, I, R. There's my triangle. So 120 volts, that's easy. That is V equals 120. Notice it has lots of different names. It can be voltage, it can be potential difference, it can be volts. Anyways, 120 volts is V. And then amps is always I, so I equals 25 amps. And I'm trying to find the resistance here, right? And so I'm trying to find R equals question mark. And so I look over here and I say, okay, here's my R, so it's going to be V over I. So R equals V over I. It's already solved. Plug it in. R is equal to 120 volts over. This one's not so easy. So let's pull out that calculator. Pull out the calculator. Maybe my calculator doesn't want to work. Let's try again. Hang on. All right, there we go. So 120 divided by 25 is 4.8. And then we have to figure out what the units are and go, volts over amps. Well, that's an ohm, right? So 4.8, that's a point. I know my points don't look much like points. 4.8 ohms. All right, how much current flows through a 100-watt light bulb? Oh, watts, that's a new one. So remember, watts is power. So P equals 100 watts. There's my voltage again. So V is equal to 120 volts. So how much current flows through a 100 watt light bulb connected to a 120 volt socket? So I'm trying to find current. We know that's I. And so now I need an equation for I. Well, we can make another triangle. It's not Ohm's triangle, but remember P is equal to IV. So I can always write these equations in my triangle format. So if P equals IV and I want to find I, then I see, oh, it's P over V. Cool. So then I can say I is equal to P over V, already solved. I can plug it in, so I is equal to 100 watts over 120 volts. All right, so I got to plug that in. Let's get to that. My calculator is not behaving. Here we go. So 100 divided by 120, and that's 0.83. And the question is the units, but we know it's I, so we know it's amps. So 0.83 amps. Good. Last one. How much energy is used by, oh my goodness, this one we don't have to do in 5 steps. This one we just have to do conversion. So we're going to do one of those train track things. 100 watts is 100 joules per 1 second. And I want to know in 1 day. So I want to figure out energy. Energy is joules, right? Let's make this, you can read it. Right? So energy is joules. And so I have, let's see, I want to get rid of seconds and I want to turn it to days. I have no idea how many seconds are in a day, but I know there are 24 hours in 1 day. Okay, good. So that means I can cancel out nothing, right? So it just sits there. But I get my days, which is what I wanted, right? Because I wanted it in a day. So I've got that, but the hours and the seconds don't cancel at all. But I know how many seconds are in an hour. I know there's 3,600 seconds in an hour, and I want the seconds to cancel. So I'm going to put the 3,600 seconds on the top, and that's in 1 hour. Right? So now I can see, okay, now the hours cancel and the seconds cancel, and so I'm going to be left with just joules per day, which is what I wanted. So I plug in my calculator and I go 100 times 24 times 3,600, and that comes out to be 8,640,000 joules. That's a lot in a 100 watt light bulb. That's how many joules you use every day. That's it.